And in this video, we're going to discuss the moon, give a little introduction to the moon, and talk about its formation, talk about history of observation, some of the surface features. And so let's go ahead and commence. So the Greeks, of course, viewed the lunar eclipses, and if you take a look here, the moon is moving into the shadow of the Earth. You'll see a curved shape, and the Greeks realized the Earth was a sphere, not flat, because the eclipses always have a curve. It takes a spherical shape to always cast a shadow that, as the moon goes in, it's a curve between the dark and white light. If we lived on a flat Earth or rectangle or something, sometimes the eclipse shadow would have a straight edge to it. But we have this eclipse of the moon, of course, light filtering through the Earth's atmosphere. Even though the moon is totally eclipsed, it's still visible. Moon map made by Harriot in 1609, and going from memory just a little bit, but I believe this was in England, and this preceded Galileo by a little bit. But Harriot did not widely publicize his observations, and Galileo really did publicize and gets more of the credit for using a telescope for astronomy observations. Galileo, described rough mountains and seas, the flat area, the Maria. So 1700s, people start to speculate as to what the moon is like. They're seeing craters. Well, we have craters on the Earth, but most of them are volcanoes. The impact craters are more rare for the Earth. They get covered up, vegetation and such. So the volcanic craters was the hypothesis of just extend what we know on the Earth to the moon. So imagine the craters are volcanoes and gas is coming out of those volcanoes, speculation that the moon has a thin atmosphere. Astronomers in the 1700s knew it did not have a thick atmosphere because you never see any clouds passing in front of the moon unless they're in the Earth's atmosphere in front of your telescope. But they speculated thin atmosphere and speculated vegetation for some of the different colored areas of the surface. Not true. But good speculation for science fiction. You can write a story about taking a rocket ride to the moon, from the Earth to the moon by Jules Verne. So, importance of the moon to us. It does have a cultural significance to it. The moon has been observed for, since before history started to be written down. In England and Ireland and Europe, there are stone circles. Calendars were invented that were based on the lunar cycle. The moon has influenced writings and poetry, influenced music. The scientific importance of the moon is that it gives tides. It has this effect of moving the oceans around, and there are consequences. We've already talked about that. The moon also provides stability for the rotational spin of the Earth. Without the moon, our axis could wander more and put Nebraska at the North Pole of the Earth. So it's nice that we have a stable rotation, and the moon helps provide that. In the future, the moon is a natural stopping off point to get water from the deep lunar craters, to process that water into rocket fuel by dissociation of hydrogen and oxygen. Gravity is not strong on the moon, so it's easier then to lift off, take a rocket journey from the moon to explore the rest of the solar system. It's kind of a nice base camp to then go out from. The moon is much different compared to the moons of other planets. Our moon has a lot of mass compared to the other moons of Jupiter or Saturn and such. If you take the Earth's mass and divide by 81, you get the mass of the moon. So the moon is not nearly the mass of the Earth. You have to divide the Earth's mass by 81 to get the mass of the Moon. But that's a bit bigger mass compared to the home planet than, say, for Jupiter. The largest moon of Jupiter, you divide Jupiter's mass by 12,600 and you come up with the mass of the Moon. You only have to divide the Earth's mass by 81 to get the mass of our Moon. So it's unusual. The Moon is unusual. It has a lot of mass compared to its host planet, the Earth. Another very unusual thing is for the large moons of the planets tend to orbit in the plane of the equator of that planet. Not so for the Moon. The Moon's orbit is more or less along the ecliptic, about 5 degrees off of the ecliptic, but nearly along the ecliptic. And the ecliptic is not on the celestial equator of the sky. The Moon is very unusual. It does not orbit around the Earth above the Earth's equator. So, how do we get a moon? One early theory was that the Moon wandered near the Earth and the Earth's gravity captured it, but the Moon formed some other place in the solar system. There are difficulties with this hypothesis. Earth's gravity is really not that strong to catch a massive body like the Moon and slow it down and bring it into orbit. It's tough for the Earth's gravity to do that. Another problem, the Apollo moon landings brought back over 800 pounds of moon rocks. They've been analyzed for their composition, and they find that they're similar to the Earth's crust. It's not similar to an asteroid. The asteroids form in other places of the solar system. So it looks more like the Moon shares something with the Earth, similar composition. The Moon apparently did not form some other place in the solar system and then get captured. Its composition is too much like the Earth, not like an asteroid. Well, maybe the Moon formed at the same time as the Earth. We have the two objects forming near each other. This would tend to have them have the same composition. Well, inside the Moon, there's not as much iron as what the Earth has. And if they formed in the same region of space, we would think that the Moon would have the same heavy elements as the Earth. Not so. The Moon lacks iron. So we don't think this double formation theory is correct. Spin theory. Suppose the Earth is molten and it spins very fast. It would be hard for the material at the outer edge to stay near the planet. Gravity has to supply the force that keeps this mass moving in a circle. And if the spin speed is too high, then gravity can't prevent a little blob of mass from breaking off and moving away from the Earth. A difficulty with this is that astronomers do not think the Earth was spinning fast enough for this effect to take place. And if the Earth is molten here and spinning, then differentiation's not occurred yet, and there should be iron scattered throughout the material at the outside where the Moon breaks off. The Moon should have more iron. It does not have more iron. So we don't think the spin theory is correct. Here's the one we think is correct, the giant impact theory. In the early solar system, there were more large objects orbiting the Sun, and one of those is speculated to be about the size of Mars. It's not Mars, but just an asteroid, a big rock about the size of Mars, and it collides with the Earth in kind of a glancing blow. The impact then is not head-on. It doesn't split the Earth in two. Instead, it gouges off some crust of the Earth, and that crust material moves out, and gravity then helps that crust material to recombine and form the Moon. Now our data agrees with our predictions of the theory. If the material that makes the Moon is being thrown out from the Earth's crust by this impact, then the composition of the Moon should be like the Earth's crust, and it is. The moon's orbit is in the orbital plane of large objects in the solar system. It's on the ecliptic. The 8 planets orbit the sun along this plane, near this plane called the ecliptic plane. So it's reasonable to assume in the early solar system there was some large object moving along the ecliptic and in the plane of the Earth's orbit around the sun, and crossed paths with the Earth, collided with the Earth, and as a consequence of the large object initially being in the orbital plane of the Earth, the material stays in the orbital plane of the moon, of the Earth. It's material that's been kicked off from the Earth. So that explains why the moon orbits around the Earth, and from our point of view on the sky, near the ecliptic. So here's a little blow by blow here of the giant impact theory. Many years ago, we have an object that collides here with the Earth and splashes out material. That material does not fall back to the Earth, but some of it condenses and forms our moon. That's a lot of names. So don't worry about this too much, other than the fact that you should know that there are these circular mare regions, and then we have roughly cratered highland regions, or more craters, mountains. We have young craters with rays that extend outward from the crater. And we always see this side of the moon, the near side, because the moon is in tidal lock with the Earth. Here's what the far side of the moon looks like, and basically no Maria. Here's one of those gray smooth areas, but it's not widespread on the far side of the moon. There has been water, ice, discovered on the moon. Just as we talked about for Mercury, near the poles, sunlight doesn't reach the bottom of some of these craters. Comets would bring material into the moon, and that material, after the impact, would settle inside the crater. Sunlight's not going to warm up that material such that it evaporates and escapes from the moon. Instead, it stays solid. So there is water ice and craters at the poles of the moon. And perhaps this will be the place that you live on the moon. Live up on the rim so you're in sunlight, but go down to the bottom to bring back water. It's not completely straightforward. There are some impurities in that water that have to be filtered out, but it is a source of water. And here's an example in the south pole of the moon where they did find this water. Pretty dark in here. Sunlight doesn't get to the bottom of that crater. So that's where this video is going to stop. We have a moon that is much larger relative to the host planet compared to any other planet in the solar system. The moon is relatively large. It's believed to have been formed by an impact of a large object in the early solar system and the Earth that tore off crust material from the Earth. And the moon now has that composition of crust material. So you should keep reading and ask questions.